In this lesson, we continue with our discussion of numeric and geometric patterns. We started this discussion in some 1 or 2 lessons ago. We want to carry on with it. We want to carry on with our discussion of numeric and geometric patterns. In that previous lesson, we looked at how different patterns can be formed, and we looked at how different patterns are used for different purposes. So in this lesson, we would like to restrict our discussion of patterns, that is numeric patterns that are based on numbers, that we call them numeric patterns, and also geometric patterns. So as is indicated here, and as we started earlier, we expect that by the end of this chapter, you will be able to create by yourself, to recognize for yourself, to describe by yourself, extend and make generalizations about numeric and geometric patterns. Basically, you will be able to have a proper understanding of what numeric and geometric patterns are. Now, patterns allow us to make predictions, okay? Because we already know the pattern of how something is happening, we can be able to forecast or to tell what might happen after some period of time. That is to make predictions. Now, you will also be able to work with different representations of patterns, such as flow diagrams and tables. Now, our discussion of pattern is a lot easier when we break it into sections. So the first section being the term-to-term relationship in a sequence, okay? The term-to-term relationship in a sequence. So let's get to that right away, and we see how we can investigate. How can we describe a pattern based on one term, okay? How can we describe a pattern based on one term or the next term? And by the way, what does it mean, a term? Okay, we want to look at that into detail and see what happens. So that is what we would like to look at. So what we'll now be doing is to get right away to the page where we are going to be getting some practice questions to help us have a good understanding of this concept of term to term when we are describing what? When we are describing patterns. So let's go right away to it. So yes, here we are, where we would like to investigate the numeric and geometric patterns based on the first section, being the term-to-term relationship in a sequence. Now, before we look at that right away, we would like to find, or we would like to get the definitions of some of these things. What does it mean, a term? Well, every number in a sequence is called a term. And list of numbers that forms a pattern is called a sequence. So for example, when you look at this, okay? When you look at sequence A, the fact that sequence A is described as the first sequence, that then means these numbers that we have here, this list of numbers, okay, they form a pattern. What that means is that there is how these numbers are formed. And if you get that bit of how the numbers are formed, that means you have got the pattern and you can now generate many more numbers. Now that is what it means, okay? So a pattern or a list of numbers that forms a pattern is called a sequence. And each number in the sequence is called a term, with 2 being the first term for sequence A, 5 being the second term, 8 being the third term, 11 being the fourth term, 14 being the fifth term, 17 being the what? The sixth term, 20 being the seventh term, and 23 being the 8th term. So yes, this is called sequence A. There are times when you may be required to find the next 2 or next 3 sequences. Okay, you may be required to find the next 3 numbers in a given sequence. So let's say this is sequence A. You may be required to find what? The next 3 terms. Now that is what we are talking about, the next 3 numbers in the sequence. So if you're required to do that, the first thing is for you to establish what is the pattern, how is the pattern formed. When you look at the first number, how do we get the second number from the first number? Well, when you look at the second number, how do we get the third number from the second number? That type of question will help you to go ahead and establish a pattern which will work for all the numbers in the given sequence. So for example, if you are required to determine or to write, for example, well, as the question here is saying, write down the next 3 numbers in each of the sequences below. That is one. Then later, you are required to also explain in writing in each of the cases, okay? You have to explain in writing in each of the cases how you figured out what numbers should be. So the next 3 numbers in this first sequence, sequence A, well, the first sequence being 2, the second sequence, or rather the first term being 2, the second term being 5. So the question here is, how can we get 5 from 2? Then, after that, how can we get the next number 8 from 5? Because the pattern you have used to find 5 from 2 must also apply when you're finding 8 from 5. So how do you do that? Well, there are so many ways that we can use to do what? That we can use to investigate or to determine whether 5 is got from 2 by, say, adding or by subtracting something. Well, since 5 is greater than 2, we would like to think that to get 5, you must add some number onto what? You must add some number onto 2. See that? To get 5, you must add some number onto 2. Now, you could also multiply 2 with some other number. You see, that is also a possibility. You could go ahead and multiply what? And multiply 2 with some other number. So the number we want to get is 5. How do you get that? Well, the first number is 2. Let's consider adding 3. Well, we can get that. Someone could also say onto 5, since 2 is already there, we can do what? We can just multiply, okay? We can multiply the number 2 by what? By 2, 5. Well, we still get 5. As I indicated, there are so many ways we can use to establish a pattern. We can either add a constant number or we can subtract a constant number. That is 1. 2, we can either multiply a constant number or we can also divide a constant number. Plus, there are other ways which we'll also be looking at. So now the question here is, since we have got these 2, this is our first attempt, okay? We're going to call it our first attempt. So the first attempt here is to see if we can do what? Is to see if we can go ahead with the either adding or multiplying. Now our second attempt, the second attempt now seeks to duplicate what we have done in the first attempt and see if we can produce the next number. Okay, so we are going to call this the what? The second attempt. So the number we want to find in this case is 8. And we want to find 8 from the what? From the number 5. That is from one term to the other term. We started with the 2. We used 2 to find 5. Now we want to use 5 to find 8. That is term to term relationship. Okay. So that way, well, we can then see we added 3 for the first time. And what did we get? We get, for the first one, we got 5 after adding 3 to 2. Now here, we would like to see if we add 5, rather 3 to 5, can we get 8? If we can get 8, that's a good thing. Let's check and see if we can duplicate what we did. So now, this time when we multiply 5, okay, by 2.5, well, 5 by 2, 5. Are we able to get 8? No, we are not able to get 8. So basically what we are seeing here is that the pattern which is going to help, which is going to work for us, is the pattern of adding 3 to the previous term. So the solution to this question, okay? The solution to this question, which we can call activity 1, at activity 1 sequence A, okay? Activity 1 sequence A. The question was, we find the next 3 terms. So the first term being 2, okay? The next term being 5, all right? The next term being 8, the next term being 11, the next term being 14, the next term being 17, the next term being 20, the next term being 23. Well, what we have seen is that we can get the next 3 terms by doing what? By simply adding 3 to the previous term. So we add 3 to 23, and what do we get? We get 26. Then we add 3 to 26 and we get 29. Then we add 3 to 29 and we get what? We get 32. So these last 3 numbers here are the numbers that they were asking for. So that is how we get the pattern. Now, if we have to write it down, okay? In this case, we are required to write down how we have got this whole thing. So to write down, to write this down, let's see. All right, so to write this down, the how bit of us forming this pattern, what we did was we added 3 to every previous term, okay? So the explanation is add 3 to the previous term. Just that. To the previous term. Yes, that's the pattern. That is what? That is how we do it. We add 3 to the previous term. And what do we get? Well, we get the exact pattern. Now, we also did something similar to this in one of the previous lessons. I just did this as a brief recap of what we have already done. Now, I would like us to look at this set of questions that I guess we can do to help us have a better understanding of what we are supposed to be dealing with. So, yes, this is the question that I would like us to deal with. Now, this question here is requiring us to first look at the patterns and then we explain the rules in our own words, okay? That is how this sequence are being formed. So you see, there is sequence in part A, there is sequence in part B, there is sequence in part C, sequence D, E, F, G, H, I, J. So now if we are supposed to look at these patterns and we explain the rule, that is only possible, well, this is only possible after first establishing how, you know, the numbers in the sequences. The numbers in these given sequences are being formed. For example, when you look at the first sequence starting with 3, so we say the first term is 3, the next term is 7, the other term is 11, the other term is 15. Now, to describe what has happened here, we need to find out how they got 7 from 3. Now, is it the same? Is it the same thing that they did to find 11 from 7? Well, notice that 7 is greater than 3. So, for example, we expect two things. We either expect addition or multiplication. If we add 4 to 3, we can get 7. And also notice, there is a number we can multiply with 3 and get 7. Okay? All right. The first one we started with was what? Was adding 4 to 3. And we got what? We got 7. If we add 4 to 7, can we still get 11? Well, turns out that we can. Yes, we can get. So let's see this right away. I'm going to be using a calculator just to help with the backup bit of addition, multiplication, and the other stuffs, okay? So what we have here is this. So we added 4, well, onto 3, we added 4. We got 7. Now onto 7, if we add another 4, we can get 11, you see? Then onto 11, if we add another 4, we get 15. So basically we can say the numbers here, or these terms, they are formed by adding 4 onto the previous term. You see? So the description, the explanation for the description would be to add 4 to the previous term. So we say, okay, for this activity. Now notice this is a different activity from the one we started with, from the one that I used to explain for you the what? The basic concepts. So here, let's move on to this. So we say this is activity A. Okay, this activity 1, say part A. Activity 1, part A. So we are only describing the rule. What is the rule? Well, we have seen that when we add 4 to 3, okay, when we add 4 to 3, we get 7. Also, when we add 4 to 7, we get 11. And when we add 4 to 11, we get 15. So the rule in this case is to add, okay, we add what? We add 4 onto the previous term. Onto the previous term. Yes, that's the rule. Now, notice that I have been spacing with this dash here. This is used for spacing. It does not mean minus or what. The rule here is add 4 onto the what? Onto the previous term. Now, when we look at the second question, the second question is asking for also an explanation for the rule, okay? So here, explain the rules in your own words, the rules used here, okay? So now, how are we going to find the rules in this case? The first number is 1, the second number is 4, the next number is 9, followed by 16. So we want to get 4 from 1. Well, the possibilities are that we can either multiply 4, rather 1 by 4, okay? Or instead of that, we can also do what? Well, let's have this writing board of ours right this side now. Yes, this is where we are going to have our board. All right, so we are now moving to activity 2. Activity 2, rather activity 1 part B. Yes, activity 1 part B. The sequence here is 1, then 4, then 9, and then what? 16. So we want to find a way that is used to do what? We want to find a way which is used to find these other numbers, the first number being 4. Well, our suggestion was that we could multiply 1 by 4 and we get 4. The question is, can we multiply the next term, which is 4 by 4, and we get 9? You see, it doesn't work. So what else then? Well, now notice that in this case, it's going to be a little bit different for us, okay? It's going to be a little bit tricky. We will not be able to deal with term to term kind of relationship. This one is going to be jumping from term to position. So this number is taking the first position, this is taking the second position, this is taking the third position, and this is taking the what? The fourth position. And what this then means is that we can square the first position. That is, we can square the first position, which is what? Which is 1. Then for the next, we square the second position, which is what? The second position is 2. Then for the other one, we square the what? The third position, which is what? 3. So we then be having the square of the fourth position. You see how we have now moved? Like that. So in this case, we are not relying on the term-to-term type of relationship. We are now looking at term and position relationship. So we square the first position and we get the first term. We square the second position, we get the second term. We square the third position, we get the what? Third term. And we square the fourth position and we get the what? The fourth term. What that means is, in case we are required to find the other next numbers, we keep squaring the what? The position that those numbers are standing in for. So 1 is in the first position, 4 is in the second position, 9 is in the third position, 16 is in the what? Fourth position. So, well, that is how we do what? We generate what we are talking about. And so in our own words, what is going to be what? What's going to be the explanation, the description? Well, the explanation is for us to square, okay? In this case, we square the position of the numbers, okay? Or the position of the terms. So it will be square the term position. Yes, when we square the term position, we get everything right. Then now, in the next activity, it's going to be activity 1, part C. Let's see what we have been given in activity 1, part C. So yes, in activity 1, part C, which will require me to move our writing board this side. Well, activity 1, part C. Just a minute. Yes, activity 1 part C, we have 20, 17, 14, and what? And 11. 20, 17, 14, 11. So the question is, how are these numbers formed? Well, how do we determine that? Now, notice that the first number taking the first position is 20, or the first term is 20, the second term is 17, the third term is 14, and the fourth term is 11. Now, what we are supposed to do in this case is we have to describe how this pattern is being formed. Now, since the first number is 20 and the second number is 17 less than 20, that is, the second number is 17, a number which is less than 20, the thing we want to do in this case is to establish what happened. So there is no way they added something. Instead, they possibly subtracted a number from 20, or they divided 20. Well, the option of dividing 20 will not be a very good idea for us. You know, reducing 20 to get 17. Let's stick to subtracting. So notice that when we subtract 3 from 20, we can get what? We can get 17. The question now is, can we also subtract 3 from 17 to get 14? Well, turns out that that's the deal. So we can then have 20 minus 3. You see, that is for the first term. Then for the second term, what do we have? Well, for the second term, we also have 17. Sorry, the first term is just 20. The first term is just 20. Then the second term is 20 minus 3. Then the third term is what? 17 minus 3. Then the fourth term, well, the fourth term is going to be 14 minus 3. Like that. So now notice that the deal here is for us to keep subtracting 3. Okay? We subtract 3 from each term. Then we get the what? We subtract 3 from the previous term to get the next term. Okay? We subtract 3 from the previous term to get the next term. So that is going to be our rule. The rule is subtract 3 from what? From the previous term. From the previous term. From the previous term to get the next term, or to get the required term. So yes, that's the rule that we do what? That's the rule that we use. So that is how we would handle activity 1 part C. Well, how about activity 1 part D? Well, let's see activity 1 part D right away. Activity 1 part D. Activity 1 part D is this number here. Well, the sequence starts with the number 3, 6, 12, and 24. So we say activity 1 part D. The number starts with 3, then the number is 6, then followed by what? Followed by 12, then followed by 24. Well, the question is, how do we get to that? How do we get this pattern? How do we get this pattern? The sequence is there. How do you get the pattern? How do you get the next numbers in case it's required? You see? So what we have in this case is we now have to deal with the relationship. Now notice that from 3 being the first number, we got 6. Now the thing here is something must have been added onto 3, or something was used to multiply 3. All right, let's see how this is going to come out. 2 options. If we add 3, to 3, we get 6. Now, can we add 3 to 6 to get 12? You see, it isn't work. Doesn't work like that. Well, then now let's look at the option of multiplying. If we multiply 3 by 2, we get 6. Can we then multiply 6 by 2 and get 12? Well, turns out that that one works, because we can also multiply 12 by 2 to get 24, but the option of adding would not work. So what do we do in this case? Well, the rule we have seen here is that from 3, if we want to get the next term, we do what? We multiply 3 by 2. Now, if we want to get the other term, we then multiply 6, okay? 6 by what? We multiply 6 by 2. When we multiply 6 by 2, we get what? We get the next term, which is what? Which is the third term. And to get the fourth term being 24, we now multiply 12 with what? 12 by 2. So when we multiply 12 by 2, what we get is a 24. So yes, this is the rule that we what? That we follow. Well, we could put it inside the bracket just to have it, yeah, like that. Then for this one, we also have it inside the bracket right away. And this one also inside the bracket, you know, proper casing. All right, so that's what we have now. So how are we going to describe this? Okay, well, we just say multiply, you know, multiply the previous term by 2 to get the current term. Okay, you multiply the previous term by 2 to get the current term. So that's going to be our explanation. Multiply the what? The previous term. The previous term by 2. By 2 to get the current term. And to find the next term, you multiply the current term by 2. So that would be the description. Okay. Now we will be moving on to the next activity, which is what? Which is activity 1 part. This one was part D. That means we're moving on to part E. Let's see activity 1 part E right away. So activity 1 part E, it's right on the left. So there we go. Well, the first number is 0. The second number is 1. The third number is 1. The fourth number is what? Is 2. Okay. Then the other number is what? 3. Then the next number is 5. Well, what type of pattern is this? How are we going to generate the pattern? What type of sequence is this? How are we going to establish a relationship between, you know, the terms given? The first number being 1, the second, rather 0, the second number being 1, the third number 1. So what do we do? Okay. So, well, from 0, we can find 1 when we add 1 to 0. Very much like the identity what? The identity property of addition. Then when we add 1 to 0, we can get 1. But when we add 1 to 1, we cannot get 1. We are going to get 2. See? And we cannot multiply 0 by anything to get 1. So what is this supposed to mean? Well, it turns out that if we are really interested in finding the pattern for this case, then we have to add the last 2 terms of the sequence to get the next term. You see? We add the last 2 terms to get the what? To get the next term. So very much like saying, if we want to get the third term, we must add what? The first and the second. Then if we want to get the fourth term, we must add the what? The second and the third. If we want to get the fifth term, we must get the what? Add the fourth and the third. You see that? Because when we add 0 to 1, we get 1. When we add 1 to 1, we get 2. When we add 1 to 2, we get 3. When we add 2 to 3, we get 5. Meaning to find the next term, which comes here, we must add 3 to 5, and we get 8. Then now the next term will be 5 plus 8. You see, that's the pattern. Okay, so the description is, well, from 0 to find the next term, what do? We be like 0 plus 1. Okay, then to find the next term, we be like 1 plus 1. Okay, then to find the next term, will be like 1 plus 2. Okay, wait, 0 here, yes, then 0 plus 1 for the second term. Then for the third, 0 plus 1 for the second term. Then for the third term, 1 plus 1. Then for the fourth term, this is first term 0, second term 1. Third term is supposed to be, third term is 1. Oh, okay, wait, how did we get this? This is not supposed to be here. This is just supposed to be 1. Like that, yes. Because the rule is that we add the last 2. We have to add the last 2 to get the what? The current term. So that's where things change a little bit. So yes, apart from this 0 and the 1, now to move to this, we have to add 0 to 1 to find the third term, right? Yeah, to find the third term, we have to add 0 to 1. Then the fourth term, we must add what? 1 to 1. Okay, then the next term will then now be 1 and 2. So we'll have to add 1 and 2. That is 1 and 2. Then for the next term, we will now have to add 2 and 3. Okay, we have to add 2 and 3. Like that. And it can continue. So that will give you the first term 1, the second term 1, the third term 1, then the fourth term 2, the fifth term 3, the sixth term 5. So in description, in words, you would say things like add the last 2 terms of the sequence to get the what? To get the next term. So we say add the last 2 terms. Last 2 terms of the sequence. Okay, you add the last 2 terms of the sequence. To do what? To get the next term. Like that. And yes, that leads us to the conclusion of our discussion. Just notice that there are so many ways of generating a pattern, okay? There are so many ways of getting a pattern. And once you have got a pattern, okay? Once you have got a pattern, the next thing you want to do is to describe how to find the additional numbers, because once you have got the pattern, it's like you have got the code. So let's stop there.
Oh, it's that.